The first presentation is the unique challenges for developing civil engineering infrastructures on the moon. Is given by Professor Ramesh Malla at the Structural Engineering and Applied Mechanics Department of Civil and Environmental Engineering at the University of Connecticut. He has more than 40 years of teaching, research, and industrial experience, including 37 years at UConn. In addition to being a faculty member, Ramesh worked as a structural engineer at United Engineers and Constructors Incorporation in Philadelphia, Pennsylvania, a visiting faculty fellow at the NASA Lewis, or currently Glenn Research Center in Cleveland, Ohio, and a visiting faculty at Hamilton Sundstrand Space System International Incorporation, now as Collins Aerospace in Connecticut, and as well as the founding UConn campus director of the NASA Connecticut Space Grant College Consortium. His research areas include structural engineering and applied mechanics, dynamics and vibrations of structures, finite element modeling, and analysis. His research encompasses structural on Earth, in space, and on the moon. His research work has been supported by 20 federal, state, and regional agencies, as well as industry, including prestigious federal agencies such as NSF, NASA, US Army, US DOT, as well as the US Navy. So please welcome Professor Ramesh for the talk.
Good afternoon. I think I lost all my time in introduction, so I don't think I have to talk much here. But I'm going to talk something very out of the box, maybe for many of us here. But this is very exciting. Very exciting. I'm very excited. I can go 2 hours to talk with you on this, but I have limited time. Amanda is warning me already. You always go over the time, so I'm trying to make her happy today. So I have a lot of slides, but I'm going to skip most of them. Right? How about that? We will focus on few slides. But it is very, very interesting. You'll believe me when I go through these slides. For civil engineers, this exciting time. I'm telling you, it's an exciting time. This is the time to go to the moon. If we don't go to the moon, nothing gonna happen. Civil engineers have to take the lead. That's my slogan. It's been from 90s, 88. From 90, I started working in the lunar structure. My passion in lunar structure, but I have to win my bread and butter. So I do all civil engineering structure here for the grand purpose, right? But I did PhD in space structure, space station kind of structure, and then I moved to lunar structure from early 90s. Since then, I'm working here. So I'm going to share with you some slide, but it's overall, okay, the high level introduction of what civil engineers can do on the moon. It may not be all geotechnical, some aspects geotechnical, but mostly infrastructure. Let's begin without any further delay. All right, this is me. You already know. You already got my introduction. So basically, as I mentioned, I'll go to the high-level introduction of what civil engineers can do. What are the challenging things we may encounter, okay? Not only we may encounter, we will encounter while building infrastructure on the moon, okay? Also, I will mention you something the AC Aerospace Division doing. How many people knew AC has Aerospace Division? One person, okay, few. A lot of us, we didn't know. AC has Aerospace Division. It's been there from 1971, by the way, 1971. So this AC Aerospace Division also has the Earth and Space Conference every 2 years. So next year is going to be in Miami, 2024. So that brings all the NASA and other industry people there. Okay, let me go further on the slide. This video I have, but doesn't play, as Amanda said, so I'm going to skip that one. That's the surface of the moon. So first question, why do we go to the moon? What is there? Well, people want to go to the moon. So let's look into few of the points for this. I listed some of them. Moon has a lot of natural resources, as you may know, and also it has a helium-3, which is good for energy. It's maybe stepping stone to go to further into other planets, right? And a lot of medical research we can do, scientific new ideas. You know, you work in the new challenging environment, you're gonna bring back the knowledge here. Now, as you know, all Apollo mission created a lot of new innovation on our planet too. So there are quite a few advantages. So just a comparison slide here. I'm not gonna spend time on this, but I will go through this information after this slide also. The main thing there is, if you look at temperature on the moon, the temperature fluctuates from minus 233 degrees Celsius to 123 degrees Celsius. Now, it's a very extreme temperature on the moon we have, right? So moon is 1/6 of the Earth gravity-wise. So the gravity on the moon is 1/6 of the Earth. And moon doesn't have atmosphere, as you know. As you see, a moon is more or less like a hard vacuum. The moon surface is covered with something they call fluff, is dust, right? And then, but below that dust, though, is a very compacted soil, very strong and compacted dry soil. As you know, moon doesn't have any weather. So if you look at here, let's go back. You see the footprint that clearly shows it's an astronaut footprint from the Apollo mission. Clearly shows a lot of dust there, and very abrasive dust. And it sticks to everything, by the way. It sticks to the astronaut suit, stick to the engine, you know, everywhere. The window was completely covered with this dust when the Apollo lander landed there. Challenging stuff to work on. So these are the environmental elements on the moon: lack of atmosphere, a hard vacuum, right? Extreme temperature variation, as I just mentioned. It has a reduced gravity, of course, 1/6 of the Earth. It's a very high radiation. Now, since that it doesn't have an atmosphere, the sun's ray directly comes to the lunar surface, right? So it's a very the radiation, continuous radiation. So it will, of course, damage material. People, of course, cannot survive in that environment. And also, due to lack of environment, the micrometeorite come directly hit the surface. Now you see micrometeorite coming and hitting our structure, right? We really have to design structure to resist those kind of loading. And we have a dust, as I mentioned, it's a very abrasive dust. And also, you may believe or not, but moon also has moon quakes. Very interesting. Moon has moon quakes, but it's not a very high magnitude, but it does have a ground motion. All right, if you look at the lack of atmosphere, as I mentioned here, our challenge, if you want to build structure, habitat, or a storage facility, right, or the launching pad, landing pad, right, or the solar tower. Now, what NASA is planning to do now is the first thing they are looking for two things. One is the launch and landing pad, because they have to take things from here, right? Another is the solar power station. So the idea there is, as you know, they are trying to land on the lunar south pole. So that has a lot of crater, and some craters are dark. There's no sun all the time. So they're trying to build a tower, 50-meter tall tower, okay, and they put a solar panel on top. So those kind of things they're trying to do. So we got to look into now, because no atmosphere, so the meteorite come and hit directly, the moonquake happens, right? Temperature fluctuation. So we have to design for those kind of things. So that's a thing to worry about. And extreme temperature, as I mentioned, we have never seen this kind of temperature here on Earth. And water melts at 100 degrees Celsius. It's beyond that temperature, and minus 233 degrees Celsius cold temperature. And on the moon, you may have or may not have realized, one day on the moon is same as 14 days and night long here. So it's a continuous sunshine, right? And night, same thing. One night there is here 14 days and night long. So that's why it becomes so cold and so hot. Reduced gravity is helps to make our structure thinner, but it has own issues, right? It may have a vibration issue, large deflection, all those kind of things. Let me go to another slide. High radiation. There are two kinds of radiation. One is galactic cosmic radiation, another is solar emitted radiation. And we have to design a structure for those. I mean, this is beside the biological thing. Of course, for human to survive, and it has to be the medical issues different. But even for structure, material, now you'll see the radiation will harm quite a bit. Meteorite impact, and meteorite is very, very high velocity particles, right? The meteorite, micrometeorite, which come and hit the structure on the moon is 3 kilometers per second to almost 70 kilometers per second. Now you have designed structure for that. So now that's an interesting thing, right? So these are the challenges, environmental challenges we really have to look into to build any infrastructure on the moon. So there are different aspects we have to look into also, construction, transportation constraint, okay? So we got to build our facilities so that they are transportation efficient, right? And ease of construction we have to worry about, and also we have to worry about if we build something, we could or we should expand this, right? So these are the different things in transportation we should look into. I'm not going to dwell into. I think you might have already got an idea. It's the harsh environment, how we can do the transportation facility or transportation infrastructure there. If you want to build a road, what are you going to do? What kind of material you're going to take? Now, you cannot take all material from here. We have to process the material available there. That's why people are working right now. They are trying to build concrete of lunar soil. They have a lunar simulant made here. So they are trying to use the lunar simulant to make a concrete. And there's no water on moon. They found some water, but deep underneath now. They are trying to build concrete, waterless concrete. People are studying those kind of things also. Now, the key thing is, if you want to have a city plan, right, a town plan, now the placement of different facilities, how far they should be, how far the launch pad, landing pad should be from the habitation area, right? So those are the things that are all looking to the master planning. That's a group of people working on the master planning too. So I just mentioned about the ease of constructions. Okay, I'm not gonna read the slide here. You may have gotten some idea already. Now, it's a lot of things civil engineering can contribute here. I think this is all our part of the game, right? Let me go there. Future expansion, again, as I mentioned, if you build something there, we really have to build, design, construct, right? Analyze things which could be expanded later when you need it for expansion. So that's another thing got to really worry about. So these are different things I'm showing here just to give some ideas. And after constructing of operation maintenance, another issue, right? There's a whole thing like life cycle assessment we have to do, and all kind of things. Very many things to contribute there too. And operation is another thing we do here, civil engineering, right? All the structure you make, infrastructure you make, facilities you make. You have to operate them. How are you going to do this? Now, please keep in mind, so far aerospace engineers taking things up in space, right? But as far as the planetary surface comes, as far as the lunar surface comes, Martian surface comes, right? Civil engineers, and we've been building things, we've been designing things here for what? I don't know how many years, thousands of years, right? I think we are the better place. So that's why NASA is really looking for civil engineers. Now you may not realize Bechtel, AECOM, Jacobs Engineering, they all have now the space exploration department. So the Caterpillar, they're making the equipment to build things in space. So, and Turner Construction, by the way, they are looking into expanding business for the extraterrestrial thing. And NASA has already given some contract to many companies to take the payload on the moon. So now NASA not doing themselves, they are contracting to companies. So that's a this is a very, very exciting time. So I'm gonna skip that also because I have a lot of slides, as I mentioned. Okay, I just want to go through some slide here so that I can finish something I want to share with you. Materials, by the way, civil engineering material has a lot of research to do, a lot of development to do in the material side too. Fabrication, right? So now NASA has divided this structure in 3 categories. They call pre-integrated, prefabricated, and the in situ resource utilization. The first one is everything built from here, take and just put on the lunar surface. That's what they have to do in the beginning, right? Now, you may have already heard about NASA already sent Artemis 1 mission to moon. They went around the moon rocket and came back. Next one, they're going to send with the people, but go around and come back. And third time, they're going to land on the lunar, on that moon. That will happen maybe sometime before 2030, okay, in a few years. So I'm gonna, okay, there are different type of structure they're trying to build: inflatable, subsurface, underground, and also hybrid structures. Just some graphics here, okay. And if you look at the date, 1998, this civil engineering company people, they came up with the design. Okay, Amanda is showing the sign there. I'm gonna skip more now. This is TY Lin company people wrote this paper here. They come up with a good design. And lava tube, the moon has lava tube underground. You can make underground shelters maybe there, you know. So I'm gonna quickly show some of the stuff we have done at UConn. I've been, as I mentioned, involved to lunar structure from 90s, early 90s. So we came up with idea of underground and overground, most of it going underground and some on overground, because building underground is very difficult. You have to make a crater, right? So so another concept we came is we call hybrid frame and membrane. If you look at here, this is the membrane inside, and we have a frame, civil engineering frame, basically, right? So the membrane will contain the pressure. See, anything we build there for human to live, you have to pressurize, otherwise people cannot live, right? So please think of it. Every structure they build has to be pressurized for human living. For storage may not be, but for the person to live. So we did some design concept. We came up a couple of them. Right, there's another one here, that's main habitat and airlock habitat. So I'm not gonna go. This is design concept I'm showing you, but we have done quite a bit detail analysis. I'm gonna skip this one. I'm going to go to the last few. And what we did, another very important thing, very detailed study, the temperature distribution on the lunar surface and under the surface. And also we looked into temperature distribution around the habitat. If you build a habitat, what is the temperature distribution through the thickness of the habitat, outside and inside? Very important, right? You don't want to get that 120 degrees Celsius heat coming inside. So you don't want that minus 233 degrees Celsius cold coming inside the habitat. So you want to really design how thick should be the wall. If you make a wall of anything, how thick should be that? So to do that, you got to know what temperature distribution would be through the thickness. And that's what we did. We have a several paper published on that, so I'm going to skip that one, okay? Okay, I'm just gonna do that. This is a cycle of temperature fluctuation. It goes out 400 degree Kelvin, okay, and 292 degree Kelvin is at 22 degrees Celsius, right? So I'm going to skip this. So These are through the ground. I'm going backward here. What's happening here? Oh, sorry for that. Okay, here. All right, that's the surface of the lunar. That's the lunar surface. This is through the depth of the lunar surface on top, and as you go down, around 0.5. If you look at the 25 centimeter below, that's temperature more or less constant. So I'm going to skip this also. Get a lot of temperature here. So another thing that habitat, so we took a dome kind of habitat and did some thermal studies. Here we consider the sunlight portion and also shadow portion, so self-shadowing effect. So from there also we determine a lot of equations. Let's ignore that one. But I would like to show you the temperature variation through the thickness and on the surface. Oh, sorry. Something moving there. All right. Yeah, this is the graph I want to show you. That's the surface temperature on the structure. If you look at that, it's a concrete structure, regular concrete for now, but we can use any material. 375 comes down to 225. That's a Kelvin. Okay. And this is if you look at here, it's through the depth. The blue is on the top, and as you go into the interior, so every the red line is second 0.2, and the other yellow is 0.3. It's going from outside to inside. So temperature, as you know, fluctuates right there, very bottom here, fluctuates quite moderated. So you can determine the thickness, how thick the wall should be. Now I have only a few slides. This is the one, the aerospace divisions as a space engineering construction technical committee. The committee right now is building, okay, I have 0 time, 1 minute, I'll take extra, okay? The committee is building right now a guidelines, a lunar infrastructure guideline. Okay, there are 5 teams working, 1 team working on the design load aspect. You all know ASC 7, right? Design load aspect. Another team working on construction material aspect. Third one is working on the structure design analysis aspects. 4th one working on geotechnical and foundation. And 5th one is working on the environmental effects. So the 5 teams working side by side to come up with some preliminary guidelines for the civil engineering infrastructure on the moon. So that's happening right now. And there are a lot of NASA people, industry people, academicians that are all working. So with that, I think I'm going to conclude here. So I'm not going to go there. I just give you just an introduction here. 5 groups again. Their objective I've written there. Construction material group working on their construction aspect, lunar structure design. What kind of structure should be built? How to design the structure? How to analyze the structure? Environmental effect. What kind of effect the environment will have on the structural materials and structural design aspects? Geotechnical foundation, very important, right? So to make anything, you need to worry about the site planning, site investigation, those kind of things, and foundation design. We have lastly, we have structural design and other architecture thing. So with that, I think I'm going to conclude my presentation here. I'd like to acknowledge all the help we have gotten, so many different organizations, and of course, some of the work we did at UConn, all graduate student work, and I'd like to thank them also. So finally, thank you very much for listening.